Hey everyone, I know it's been a little bit since I made a video, and ideally I'd like to get out 2 LeetCode videos a week. But what I've been doing is I've been working on this blog to go along with the channel. And if you just want to skip to the problem or to the solution, the code, then there's going to be timestamps, so you can just go right there. But let's do a quick little tour of the blog. So here's the home page, and then you can click right here to go to different topics. So we have the LeetCode topic, and then in here we'll have all of the different LeetCode problems that we've done, and like our remove duplicates from sorted array. So you can go in here, and you'll have a embedded video from YouTube that you can watch there, links for everything, and then just all of the notes written up as a blog post. And then down at the bottom, there'll be the code, and then you can just copy the code from there. Now, the other thing that I have here is ViewPress. Eventually, I'm going to be making a ViewPress series on how to create a blog, and it'll be actually how to create this blog here. And then we have a post section, so all posts, you can go through all the different posts, you can look at the posts by topic. And then we have a resources page. So eventually I'm going to have all resources to different YouTube channels, different blogs, and other resources and that I've found helpful. And then there's a donate page. So if you can donate, it's always appreciated. And if you want to donate cryptocurrency, I have Bitcoin, Ethereum, Cardano, Polkadot, Monero, Parachain, and Dara addresses. So you can just copy it. It'll copy to the clipboard, and then you can send it. And then you can also donate fiat if you want through Patreon, PayPal, Subscribestar, or you can sponsor me on GitHub. So thanks a lot for any donations. Okay. Now the blog is always going to constantly be improving and being updated, so look out for any updates to it. And a link for the blog and for ways to donate is going to be in the description down below, as well as a link for the LeetCode problem and a GitHub repo, which is going to have the code and the notes inside of it, so you can get that there. And there's also going to be a link for a Discord chat, so you can go there, ask questions, and share your solutions. And there's also going to be a link for my LinkedIn profile, so you can connect with me there. And be sure to ask questions in the comments below as well. All right, so that's enough of the channel update. So now let's get into the problem. Okay, so at any point in the video, be sure to pause it if you think that you can solve the problem, try it yourself, and then come back and you can look at my solution. All right, so here's the problem that we're going to be looking at today. It contains duplicate, and let me go through here, open it up over here. All right, so in this problem, we're given an integer array nums, and I also have this new drawing tool for, I think it's pronounced Grommet MPX, and just let me draw on the screen and stuff. It's pretty cool. So we are given an integer array nums, and we want to return true if any value appears at least twice in the array, and return false if every element is distinct. And then they give us an example down here. So if we have an input of nums of 1, 2, 3, 1, then the output is going to be true, because we have a duplicate there with 1. And then we have our example 2. So we have an input of nums with 1, 2, 3, 4. The output's false since there's no duplicates. And then they give us another example. And you can see here that we have some duplicates with these 1s here. So that's going to return true. Duplicates with the 3s and with the 4s there as well. All right. And then they give us some constraints. So the constraints are that our nums.length is greater than or equal to 1, less than or equal to 10 to the 5th, and that our nums of I, so each value in nums is going to be greater than or equal to negative 10 to the 9th and less than or equal to 10 to the 9th. All right, so my goal is to provide an intuitive solution and kind of bring you through my thought process. And be sure to pause the video and try the problem yourself, and then we'll go through my thought process. All right, so hopefully you're able to give the problem a shot and come up with a solution or start working through it. And now let's get to my thought process. All right, so let me scroll down here. So here's my thought process on it. So we are, by looking at the example over there, the first thought that comes to my mind, or to your mind too, may be to simply take each value in nums and compare it with every other value, okay? So basically we'll be comparing each pair of values in nums to see if a duplicate has occurred. All right, so to do this, we'll start at the first value in nums and compare it with each value to the right until we reach the end of nums. All right, and then we'll take the second value in nums and compare it with each value to the right until we reach the end of nums. All right, and we're going to repeat this process until we reach the end of nums in the worst case, or until we find a duplicate value. Okay, so here's a visualization for when nums is equal to 1, 2, 3, and that's going to represent a worst case scenario. All right, so let me just clear off this screen here. All right, so here is our visualization for nums is equal to 1, 2, 3. All right, and that's going to represent a worst case scenario. So we're going to take our first value in nums and compare it with each value to the right of it. So we're going to look at our first comparison here. So right here we have nums 1, 2, 3, and then we have our indices of 0, 1, 2. And we're going to compare nums of 0 with nums of 1, and they're not equal. So no duplicate was found there. So we're going to continue on, and then our second comparison, we have our nums of 0 not being equal to nums of 2. So no duplicate was found there. And then we're going to take our second value in nums and compare it with each value to the right of it. So our third comparison here, we're going to look at nums of 1, and that's not equal to nums of 2. So no duplicate was found there. All right, so the third value in nums is also the last value, so there's no more comparisons to be made at that point. All right, so to achieve this, we'll need to loop over each value in nums, and for each iteration of this loop, we need to compare our current value, which we'll denote as nums of I, with each value to the right of it. All right, so the process of comparing nums of I with each value to the right of it, well, this means that we'll need a nested for loop that loops from nums of I plus 1 to the last value in nums, and a nested for loop, well, that's going to give us a time complexity of big O of n squared, and that's not very efficient, and it's going to result in a time limit exceeded error on LeetCode. All right, so there's a better way to think about the problem, and we can get into that now. Let me clear off the screen and exit the drawing tool. All right, so here's a better way of thinking about it, which is that before checking for duplicate values, we can realize that if we sort nums, any duplicate values will be consecutive. All right, so let's visualize this with this example when nums is equal to 1, 2, 3, and 1. So sorting nums is going to give us 1, 1, 2, 3. And now we can loop over nums and check for duplicate values. So looping over nums, that's just going to give us a time complexity of big O of n. And the sorting algorithm can have a time complexity as good as big O of n log n. All right, so that'll be the case if something like heap sort is used. So the overall time complexity is going to be big O of n times log of n, since that's going to be the dominating factor there. All right, and this is a better solution than using that, our nested for loop, but it's not the best solution that we can come up with. So a better solution, let me clear this and go here, is that if we realize that solving this problem requires the ability to efficiently search for values. All right, so a great way to do that is to use a hash table. So what is a hash table, right? So a hash table is an object that basically maps keys to values. All right, so the search and insert operations in a hash table can have a time complexity of big O of 1. All right, so using a hash table will allow us to store each value in nums as a key, and we can map a value of, let's say, true to it if it's the first time we've seen the value. Okay, and now to create our hash table, we can loop over nums, then check to see if the key is present. All right, so if the key is now in nums, and if the key is present, then we have found a duplicate value and we'll return true. And if the key isn't present, then we'll store the current value of nums as a key in our hash table, okay? And with a value of true. So this value of true is kind of arbitrary, but we just want to set it to something to where that when we check the value, it will evaluate to true. So we're just going to use true for that. And if no key appears twice, then nums has no duplicates and will return false. And here's a visualization of that. Let me clear off the screen and scroll down. So here is our first iteration. And here we have nums of 0 is going to be 1 here. So we're looking at nums of 1, 2, 1 in this example. So we have nums of 0 equal 1. And then our object just starts off as an empty object, our empty hash table here. And then we'll see that nums of 0 is not a key yet. So we're going to store the value of nums of 0 as a key in our hash table with the value of true. So after doing that, our object will have that key of 1 from nums of 0, and that'll have a value of true. And then in our second iteration, we're going to look at nums of 1 equal to 2, right, from up there. And then we'll look at our object. So our object currently has a key of 1, value of true. So nums of 1 is not a key. So that means that we'll add it in. So we're going to store the value of nums of 1 as a key in our hash table with the value of true. And now our object's going to look like this. It's going to have a key of 1, value of true, key of 2, value of true. And then our third iteration, we're going to look at nums of 2, which is 1. And then we'll look at our object. So we have our key with the value of 1, or our key that is 1, and it's going to have a value of true, our key of 2 with the value of true. And then we'll see that nums of 2 is already a key, right? Because 1 is already a key in there. And since the same key appeared in our hash table, a duplicate has been found in nums, so we'll return false. All right, so hopefully now, if you didn't already come up with a solution, hopefully this helps you kind of think through different ways to come up with a solution. And then, now pause the video and see if you can solve it, and then we'll get into my implementation of it. Okay, now let's look at my implementation. Throw that over there. And here I've just copied over the function from the prompt. So we have our contains duplicate function, and we're going to use it over here as a reference so we can come up with our solution here. So we know that we want to store the values in nums as keys in our hash table. So we're going to need our hash table, right? So we'll call that const object. That'll be an empty object. And then we want to be able to loop over the values of nums and then store them as keys in our hash table here, our object or obj, I guess. And we'll do a for, and then we'll go from we'll let I equal to 0, so from the beginning of nums, and then as long as I is less than or equal to nums dot length, and then we'll increment our I there. Okay, so now we're looping over our nums. Now the next thing that we're going to want to do is we're going to want to check to see if the key is in our object, right? So we can do that with our if statement. So we'll do if our object, our obj here, and then we'll check our nums of I. Okay, so what this is doing here is we're going to pass in our nums of I, right? So nums of I of 0 is going to be, in this example, it would be 1, and then nums of 1 would be 2, and then nums of 2 would be 1 in this example. And then what this is then going to do here, when we pass it into an object here, is just going to check to see, is that a key? So is the value in nums a key? Okay, and if it is, then we're just going to return true. Okay, and if it's not, then what we are going to do is, let me do it down here outside of the for loop. So if we've gone through the whole for loop, then what we'll do is we will return false. So if we go through the whole for loop and we didn't find that our nums of I appeared again in our object, then we're just going to return false. Now we need a way of storing it in our object, and to do that, what we'll do is we will take our object here, our hash table here, and then we will set our nums of I, and that's going to be equal to true. Okay, so let's save this and then we'll run it. Let's take our nums equal to 1, 2, 1 example, and then we'll console.log, and we'll do our contains duplicate, and we will pass in nums. And for this problem, assuming that we did it correctly, we should get true back. Yep, because we contain a duplicate there. Okay, so now let's take this and put this in LeetCode so they can run their test cases against it. Just copy that in there, paste it, and submit it. And let's see what we get. And cool. All right, so we got a successful run here. So it's, good solution in terms of time complexity. We use a good amount of memory there because we were using that other hash table. So then we can, get our better time complexity, our big O of n time complexity there. All right, so hopefully that was helpful. And be sure to comment, like, subscribe, and share. And check out the blog, ask questions, and share your code in the Discord chat in the comments below. And if you can donate, be greatly appreciated. You could do that through Patreon, PayPal, Subscribestar. You can sponsor me on GitHub. Send me some cryptocurrency. All right, and thanks a lot. And I will see you in the next video.